Hello viewers, welcome to my channel and thank you for watching the videos. In this video I would like to discuss statistics, and the topic has been covered according to CSAT UPSC Prelims examination. Otherwise you may see videos which are of 12th and 10th class. So many topics you will be finding there. So let's see a few formula and examples based on that. So statistics, what is the first formula we are taking? Mean. We are finding the mean of the data. Some data has been given, so single data is there like 2, 7, 10, 15. Single means say marks of the students have been given, or the speed of cars have been given, or you can say the rate of some commodity has been given in different states or cities. So we will sum that data, and number of items, how many of them are there, means number of students. In this example is sufficient if we take a class, and in that class students are there and they are having some examinations and numbers are there. So we will stick to this and then we'll do the all questions with the help of this example. So sum of all data values upon number of data values means how many students are there or how many numbers are there, means one student got 10, another got 15. So how many of them are there, that is number of data values. So x bar, this is standard notation we have. X bar is sigma x, means summation of that data, means summation of numbers upon number of students will give you mean. We call it arithmetic mean. And another terminology is we can write x1 plus x2 up to xn. So these are the numbers of students in a subject, say, or in a total number of one student. Total marks of another is x2, xn is the total marks of nth student. So that way we can have, and x bar is mean and the data we denote by xi. So when we subtract mean from the data points, for each data point we get some value. So in general we can write down xi minus x bar, and we take summation of this. This is always 0. Summation of xi minus x bar is always 0. So we have I is taking values from 1 to n, and x bar is arithmetic mean. If x1 bar and x2 bar are respective arithmetic means of two different sets of data having a1 and a2 elements respectively, then mean of the total set is x bar is equal to a1 x1 bar plus a2 x2 bar upon a1 plus a2. So here what we did, we are having two different data sets, means marks in physics and marks in maths, and first is having a1 elements. Marks in physics are a1, means number of students are a1, and marks in maths are a2. Then the mean of total is a1 x1 bar. X1 bar is mean of physics and x2 bar is mean of maths. Geometric mean, so of a1 two numbers x1 bar plus a2 x2 bar upon a1 plus under root of ab, or a to the power half, ab to the power half, that is square root of ab. Geometric mean of n numbers, if we are having n numbers, so we will having nth root of product of these numbers, a1 a2 a3 into, this is the product of this, and nth root we will be finding out. So if we are having here, this is not comma, this is not there. Now harmonic mean, is n upon sigma I is equal to 1 to n 1 upon ai, means number of data points are n upon summation I is equal to 1 to n and 1 upon ai, and a1 a2 an are the numbers we can say. And for two numbers, so numbers are ab, so n is equal to 2 here, and sigma 1 upon ai will be 1 upon a plus 1 upon b. So this is 2ab upon a plus b. Arithmetic mean is greater than equal to geometric mean, and geometric mean is greater than equal to harmonic mean. So this is the relation which is always true. And mean of ungrouped data means data may have grouped 10 to 20, 20 to 30, 30 to 40, like this we have grouped data. And when ungrouped data, some numbers are there, as I said in previous slide, x1 plus x2 plus xn upon n. Now mean of group will give you x bar, so we call it ungrouped data also. Mean of ungrouped data means x1 is happening f1 times, so frequency is f1, x2 is happening f2 times, so x2 f2, xn fn times. So if x1 x2 xn are observed data with frequencies f1 f2 fn, then the mean will be x bar is equal to f1 x1 plus f2 x2 up to fn xn upon f1 plus f2 up to fn, which we can write in short summation of fi xi upon summation of fi, and both are having I is equal to 1 to n. So there are many formulas, just remember the formula and you can do the understand the meaning of the terms in the formula and apply that. You can do solve questions. So assumed mean method is that we are assuming that this is the mean of the data, and just we correct it. So x bar is equal to a plus sigma fi di upon sigma fi, which is equal to a plus d bar, and d bar is equal to x bar minus a. So we can write down x bar value in x bar minus a. X bar is sigma fi xi upon sigma fi, which is the mean, minus a is the assumed mean, which is sigma fi a upon sigma fi. So we write basically this as sigma fi xi minus a upon sigma fi, and xi minus a we denote by another notation d. So this is sigma fi di upon sigma fi. So this is by using assumed mean. Need not to remember this big formula. When you have data, you can apply directly, or the procedure if you learn. But if somewhere formula is being asked, then you need to know. Otherwise only question, then need not to do, only learn the procedure how to apply this in the question. So here age group has been given, class interval, and group data is there 10 to 25, 25 to 40, means interval is of 15, means same interval in each, and number of people for each group has been given 3, 11, 10, 8, 6, 2, and mean is to be calculated. So we can write the question in this form as it is written here, that this is group and this is people, frequency fi. Now we have to have xi. Xi is the midpoint of the interval. So 10, 25 means 25 minus 10, that is 25 plus 10 upon 2. 25 plus 10, to find the mean we have to add the end points of the interval and divide it by 2. So 10 plus 25 upon 2 is 17.5, and next is 25 plus 40 by 2 is 32.5. In this manner we can find out this class mark, we call it, and xi we write it xi. So this is our xi. And if it is not group data, sometimes we have xi here, which is single data. So then in that case need not to find out this midpoint, only a given data can be used. So di is equal to xi minus a is the assumed mean. So here 47.5 is the assumed mean. You can take any value, but we generally take mid value. And even I have checked that even we take first value as assumed mean or last value, then also we will get the answer, and which is correct. But generally we take mid value as the assumed mean. Like in this case exactly mid is not coming, so 2 above and 3 below. Two values are above the assumed mean and 3 are below the assumed mean, then also it will work. So xi minus a, so we have a 47.5, that is assumed mean, and from each xi we subtract this a value. So above we get always negative values and below we get always positive values. So now we got di, we have to find out fi di. So just multiply these two and find the summations. So sigma fi is summation of fi 40 and sigma fi di is 135. So when you learn the procedure it's easy to do. Now we will find the mean, and mean is a, that is assumed mean, plus sigma fi di upon sigma fi. So we get the answer 50.875. Now next measure, we call it measure mean median mode. We are doing some measure, means we are finding the mean from this data point, how much on right side, how much on left side is the data. So second measure is called median. When numbers are arranged either in ascending or descending order, median is the middle term when number of terms is odd. So when we count them, if they are odd, then the middle term will be the median. And average of middle two terms is the median when number of terms is even. So we will take two middle terms and then we will add them and divide it by 2, that is average. And median divides the distribution in two equal parts. Median of ungrouped data we arrange. So how to find that? First step is that arrange the data into ascending or descending order. Once you have done that, check whether numbers are odd or even. If numbers are odd in counting, then median will be value of the, suppose n is an odd number, so then the median will be which term? N plus 1 by 2th term will be the median. Now suppose n is an even number, then median is half of value of nth term plus value of n by 2 plus 1th term. So let's take one example, and suppose the data is 5, 15, 25, 35, then 65 and 75, and we have to find the median of this. So how many data points are there? First count them. It's already in ascending power, so they are in increasing order, so need not to rewrite them. Already in ascending power, so we count them. They are 6 data points. 2 to set 2 of. Now because it's an even numbers, so for even number median is n by 2th term plus n by 2th plus 1th term and half of that. So here these are, n is 6, so n by 2 is 3, so third term, n is 6, 6 by 2 is third term, and third plus 1 fourth term. So by 2, 25 plus 35 by 2, that now is when 30. The data is group data median, we have to find out So data in groups or classes interval. Formula is median is equal to L plus n by 2 minus Cf upon f into h, where L is the, because it's a group data, so intervals are there, so lower limit of median class. First we will find out in which median lies, because we find out cumulative frequency, and from there we decide that median will lie in this class. Once we decide that class, we take lower limit of that as L, and n is the number of observation, and Cf is the cumulative frequency of the class which is preceding the median class, and frequency of median class is f. So the previous one, that h is the class size. So here we have an example of median. So number of rooms in 50 hotels have been given, and this is less than 140, 140 to 145. This is the interval has been given. Frequency, that less than 140 is 4, 140 to 145 is 6, like this. So cumulative means we will take first value as it is, and in next we will add 4 plus 6 is 10, and 10 plus 20 is 30, 30 plus 5 is 35, and we are adding next value of frequency. So 35 plus 13 is 48, and 48 plus 2 is 50. So here n is 50. The total number of observations are 50. N by 2 is 25. So where 25 lies? It lies in this class. This is lesser than this 25, and 25 lies in this cumulative frequency, and corresponding to this the class interval is 145 and 150, this one. Now L will be the lower limit of this class interval, that is 145, and Cf is the previous cumulative frequency, that is 10, and f is 10, 20, the frequency of this class interval, which is median class interval, and h is equal to 5, the interval size. Just put these values, you will get the median. Now mode of the group data. Here also we will use the formula. Just remember these formulas: L plus f1 minus f0 upon 2 f1 minus f0 minus f2 into h. The meaning of them, that we will find the first modal class. As we found the median class, we will find the median class, modal class here, and lower limit is L. Class with maximum, and what is the modal class? The class with maximum frequency is modal class. H is size of the interval, f0 is frequency of the class preceding to the modal class, the previous one, and f1 is the frequency of modal class, and f2 is the frequency of class succeeding to the modal class, next one. So frequency of next class next to modal class. So now example is number of cars in lakhs on road of 30 different states are. So this is 1 to 3, 3 to 5, 5 to 7. This is the interval, and this shows the number of cars, and number of states, that is 10, 8, 5, 6, 1. So what is the mode of the data shown above? So modal class is here 1, 2, 3, because 10, which is the maximum frequency, which is the first one. So here this is the modal class, that is 1 to 3. So L is 1. H is the difference. Here difference between all the intervals is 2. F1 is 10. F1 is 10 means the frequency of modal class is 10. Now previous class there is nothing, so f0 is the frequency of the previous class, which is 0, because it is not existing here, and f2 is the frequency of next to modal class, so that is 8. Just put in the data, the formula of mode, and get the result. So this is the formula, and after putting the data we got 2.66 value. You can see the calculation. So empirical relationship between mean median mode is that for moderately skewed distribution, normal distribution is having a curve which is this sort of this, which is half on this side. This is straight line in between, and half of this on this side, half of this on this side. So area under the curve 50% on this side, 50% on right. Mean is in between, median mode are on the middle point, the mid half of this, and skewed means shifted to left or shifted to right. The peak has shifted. So mean median mode relationship is, for a moderately skewed distribution, the following relationship is found to be valid. Mode is equal to 3 median minus twice of mean, and skewness degree of departure from normal. The figure is same as I have shown you, where peak has been shifted. So figure is here. So mean is 39, mode 36. So mode is 3 median minus 2 mean. We get the value of median. Thank you.